Greetings and welcome to Lesson 7.5, Operations with Time and Mixed Units. So if we're dealing with unit analysis with time, it's probably the most common that we've done. We kind of instinctively, or we've grown up with, the idea that there are 60 seconds in a minute, 60 minutes in an hour, and 24 hours in a day. And we can also extend that to 7 days a week and 52 weeks in a year. So when we kind of instinctively know this, because we've looked at a clock all our lives, we may not know how to interpret or convert time formally. So here's what we're going to do. Since there are 60 seconds in a minute, our two conversion factors are either going to be 1 minute to 60 seconds or 60 seconds to 1 minute. Hours and minutes, well, there are 60 minutes in 1 hour, so our conversion factors are either 1 hour to 60 minutes or 60 minutes to 1 hour. Days and hours, well, there's 1 day per 24 hours. So again, our conversion factors are going to be 1 day to 24 hours or 24 hours to 1 day, depending on the context of our problem. And we can extend this to 7 days in a week, 52 days in a year. But have you ever asked yourself why 60 minutes in an hour or 60 seconds in a minute? And why is it only 24 hours in a day? Why isn't it 10 hours in a day? Why didn't we break up the days and the minutes and the seconds a little bit differently? We can think 3 specific groups of people as to why we have 60 seconds in a minute and 60 minutes in an hour and only 24 hours in a day. So the Babylonians back in 2000 BCE, they had I have a hard time saying this word, sexagesimal system. In other words, it was base 60. Today we use a base 10. We have 10 fingers, so we use a base 10, and we have very unique names for each number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we really just start all over again. 10, 1, 10, 2, 10, 3, 10, 4, 10, 5. But we call those 11, 12, 13, 14, 15. 10, 6, 10, 7, 10, 8, 10, 9, 10, 2 tens. So 16, 17, 18, 19, 20, and then we really do 21, 22, 23, all the way up to 30, and we keep going. So our system is a base 10 nowadays. The Babylonians had a base 60. That means they went all the way up to 60, and then they started doing 61, 62, 63, and then that was 261, 263, 264. They named them differently, but they had a base 60 system. Hence, 60 seconds in a minute, they cut those little times down into 60s. And it may not quite have been Babylonians. It could have been the Greeks, but we'll talk about that in a second. Next comes the Egyptians in about 1500 BCE. They used a base 12, which is a duodecimal system. So they would say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, deca 1, dec 2, they'd name them something else, and then they would go back to 12-1, 12-2, 12-3, just like how we have 10-1, 10-2, 10-3, meaning 11, 12, 13. So they went all the way up to 12 before they started coming back around and talking and renumbering, using the same numbers over and over and over again. So that was the Egyptian, and they actually break down the day into 12 equal segments. But they use their ration and their logic to realize that, well, if half of the time was spent in daylight, probably half of the other time was spent at night. So instead of going, since their base was 12, they said there were 12 hours in a day and 12 hours at the night. They specifically left them separate, 12-hour daylight hours, 12 hours nighttime hours. Since then, we've now combined it to 24 hours in a day, calling the whole unit daylight and nighttime a day. But really, who made the biggest change and kind of brought it all together were the Greeks. And this happened about 150 BCE. They wanted to use theoretical astronomical calculations. They were big into astronomy. And because of that, they adopted the Babylonian system of base 60 to divide a circle up into 360. So 60, 60, 60, portions of 60, and you get 360 degrees all the way around. They normalized the length of the hour depending on the, calculated based on your geographical location. So the Greeks really kind of pulled it all together for us, and we've kept it the same since 150 BCE. Our calendar has changed, by the way. There was a period of time where a couple days don't exist. We skipped some days. So if you're curious about that, use Wikipedia. The days that don't exist, you can look that up online and figure out what days those were and why those days in history actually do not exist. We skip those days. All right, so let's use unit analysis and convert time to one type of measure. So here's an example. We have 3 hours and 15 minutes. And we want to convert it first. We'll convert it all to minutes. And then second, we'll convert it to hours. So to convert it to minutes, well, 15 minutes is already in minutes. Therefore, I don't have to convert that. I just need to make sure that I add it at the end when I do convert the 3 hours. So let's set it up. 3 hours times our conversion factor. That's 60 minutes in 1 hour plus the 15 minutes that I started with. I can't forget this 15 minutes hanging out there. Okay. Whole point of this was to be able to eliminate the units of hours. And now let's convert it into minutes. 3 times 60 is 180 minutes plus 15 minutes. So that equals 195 minutes. That's our conversion to minutes. Now let's convert 3 hours and 15 minutes to all hours. Well, the good news is the 3 hours is already into hours. So I only need to add the 3 hours after I've converted the 15 minutes into hours. So 15 minutes times our conversion factor. I want to get rid of minutes, so minutes will go down on the bottom. Hour will go up on top, plus the 3 hours I started with. This time, I wanted the minutes units to go away, and they have. I'm left with 15 over 60 minutes plus, hours, plus 3 hours. 15 over 60 is 1/4. I can reduce that down to 1/4 of an hour plus 3 hours. Now I can either say that is 3 1/4 hours, or if I change this into a decimal, it would be 3.25 hours. Both of those are the same amount of times in hours. Instead of going with a conversion, I think one example pretty much will do it there. Let's go ahead and try some math on time. So I want to add 5 minutes 37 seconds and 7 minutes 45 seconds. So in other words, 5 minutes 37 seconds plus 7 minutes 45 seconds. I'm going to add the seconds together. 7 plus 5 is 12, carry the 1. 4 plus 3 is 7, plus 1 is 8. And let's add the minutes together. 5 plus 7 is 12. But here's the thing, I have to stop and think. There are 60 seconds in a minute. 82 is more than 60. Because of that, I'm going to subtract 60 seconds and add 1 minute. Okay? The 60 seconds I'm taking from the 82, I'm giving it to the minutes. That will leave 22 seconds, 13 minutes. Okay? It's a little trickier. Okay? For every 60 seconds, we're going to, in essence, carry 1. All right, so that was addition. Let's try subtraction. Let's subtract 34 minutes from 8 hours, 15 minutes. We're taking the 34 minutes away from the 8 hours, 15 minutes. So 8 hours, 15 minutes minus 34 minutes. There's our setup. But we have a problem. 15 minutes is smaller than 34 minutes. So I'm not going to be able to directly do this math. Because of that, I need to borrow, right? I can do the 5 from the 4, that's 1 minute. But I need to borrow because the 1 is smaller than the 3. Because of that, I need to borrow from the hours column. But remember, if I borrow from the hours column, that's really I'm borrowing 60 minutes. So this problem becomes I'm borrowing from the 8, 1, so that becomes a 7 hours, and I have to add 60 minutes to the 15 minutes, and I get 75 minutes, and now I can subtract the 34 minutes. So borrowing, I have to borrow the whole entire hour, meaning I have to borrow 60 minutes. Because I'm borrowing 60 minutes, I have to give it to the 15 that was already there, giving me 75 minutes. Now I can do the math. 1 minute, 7 minus 3 is 4 minutes, and 7 hours. So 34 minutes from 8 hours and 15 minutes is 7 hours, 41 minutes. Let's deal with mixed units of measure, and we're going to apply all the concepts that we've learned up to this time. So let's say Jake purchases 4 halibut. The fish costs $6 per pound. Each weighs 3 pounds, 12 ounces. What's the cost of the 4 fish? So here's the units that we're dealing with. We're dealing with pounds, ounces, and money. Okay. We can convert all the ounces to pounds or pounds to ounces, but we're not going to convert money to pounds. So here we go. We want to know what's the cost of all 4 fish. So if each pound, so it's $6 per 1 pound, that's how much we will earn. We need to know how many pounds of fish we have in total. So we can either do it one of 2 ways. Right? I'll just bring this up. First way, we can figure out how much 1 fish will cost, and then we multiply that by 4, because we have 4 fish. Or we figure out how much weight for all 4 fish, and then we multiply it by how much it costs, the $6 per pound. So I think I'm going to do both ways here. I'm going to figure out what 1 fish costs. Now I do have to check. 3 pounds, 12 ounces. All right. 1 fish was 3 pounds, 12 ounces. Because our cost is all in money per pound, I need to change this all over to pounds. Well, 3 of the pounds are already into pounds. I just have to figure out what 12 ounces, how much pounds 12 ounces is. All right, so 3 pounds plus our conversion of our 12 ounces times, well, per 1 pound, there are 16 ounces. The ounces will cancel out, leaving 3 pounds plus 12 over 16 pounds. 12 over 16, well, that's 3 over 4, so that's 3/4. So that's 3 3/4 pounds, or if we want it in decimal, that's 3.75 pounds. Right, that's for one fish. Now, I'm going to figure out how much it is for this one fish. So, my one fish weighs 3.75 pounds. I'm going to multiply it by $6 per 1 pound. Good news is pounds go away and I'm only left with money. And I just have to figure out 3.75 times 6. 5, 4, 18, 22. So, for one fish, it's 22.50. Okay. $6 per pound. One fish costs, weighed 3.75. Oh my gosh, can't talk today. So one fish, remember that's for one fish. $22.50. But we caught 4 fish. So $22.50 times the 4 will give us $90 for all 4 fish. That's figuring out the price of one fish and then multiplying it by 4. The other way I could do it is I could find out about the weight of all 4 fish. Right? If one fish weighs 3 pounds 12 ounces, then all I need to do is multiply this by 4. So I can either do it separately, and I think I will. So I'm going to do the pounds separately. Let's multiply that by 4. I get 12 pounds. I'm going to multiply the 12 ounces by 4. I get 48 ounces. But remember, there are 16 ounces in a pound. So 48 ounces times 1 pound to 16 ounces. Ounces cancels out. That leaves 48 over 16 pounds. That equals 3 pounds. Okay. 16 goes into 48 3 times. So the ounces is actually 3 pounds. So 12 pounds plus 3 pounds will equal 15 pounds of fish. That's for all 4 fish. 4 fish weigh 15 pounds. But now we have to figure out how much it costs for the 15 pounds of fish. So let's say 15 pounds times the $6 per pound. The pound goes away. I'm left with 15 times 6, and that is $90. Either way, we get $90. But depending on if you like to figure out all of the weight first and then multiply it by the money, or figure out how much one fish costs and then multiply it by 4, it's up to you. Either way will work. That's it for this video. Until next time, be seeing you.